real exam questions. This is question 7. It's about slabs and the method of equal deflection. Consider a type 2 slab which is loaded with a uniform distributed load of 10 kilonewton per square meter. Type 2 means that this direction is simply supported and the other direction is simply supported and a fixed end. How much is the load transfer in direction A and in direction B? So the question is, what is QA and what is QB? Due to a load in direction B greater than the cracking moment, the slab is now cracked in the direction of B, so that the stiffness in direction B is only 1/3 of the stiffness in direction A. How much is the load transfer now in direction A and B? And what can you conclude from this? So we look again at our slab. It's fixed at one end and the other is simply supported. We first consider uncracked. So uncracked means that the stiffness in both directions are equal, which is this. We look at the deflection at midspan for the direction of B in B. This is the deflection in midspan, and omega B is then 5. This is the direction in A span. It's simply supported and fixed. So this is the formula for the deflection at midspan. You see the 2, so omega A is now 2. We know that the sum of QA plus QB is equal to Q. And from this, you can derive this formula. You will see in this formula, it's omega A divided by omega B, but it's just this value divided by this value. When you put in the numbers, you have QA over Q is 0.442. And the load transferred at uncracked section, cross section, is then in the A direction 4.42 kilonewton per square meter, and in the B direction 5.51 kilonewton per square meter. Now we look at the cracked section. Cracked means that in the direction of B, the stiffness is 1/3 of that in the direction A. So when we look again at deflection of midspan in direction A, then we see that 2 and the stiffness are now the parameters. So omega A is now 2 divided by the stiffness in the direction of A. For B, again, the deflection at midspan and 5 and the stiffness in B is now are now the parameters. So omega B is 15 divided by the stiffness in the direction of B, or it's this stiffness in direction A divided by 3. So you got this. Now we can plug it in our formula, and you see omega A is 2 and omega B is 15. So we have now a load transfer of 0.704. And if you multiply this by Q, which is 10 kilonewton per square meter, then you see that the load transfer in direction A is 7 kilonewton per square meter, and in direction B, 3 kilonewtons per square meter. What does that mean now? For the uncracked section, this is the result. For the cracked section in direction B, so the bending moment in direction B is bigger than the cracking moment, so the cracks are going like that. Then you see that the load transfer for direction A is almost 60% increased. But at the direction of B, the load transfer is decreased. So you see that a cracked section has a significant influence on the load transfer.